Hello and welcome to another episode of Elktech. I'm your host Brian, and today I am going to be going into adapter cards and expansion slots inside of your computer. So this is, we're getting toward the end of this series of computer parts and how the computer kind of works on the inside here. So if you haven't watched the previous videos, I recommend that you go to my website and check out the rest of them, or go to my YouTube channel. There are links in the space below, so check those out if you need to check those out first. So like I said, we're going to check out adapter cards and expansion slots. So now that we've kind of chosen our motherboard, we've got our CPU, we've got our RAM, our hard drive, we've got our optical drives, the next thing that we need to look into is whether or not we need any expansion slots or expansion cards to go in the slots. So we have multiple different slots that are on our motherboard. The first one being the PCI. This is a 32-bit or a 64-bit expansion slot, and this is going to be one of the most common ones you'll see on the motherboard outside of the PCI Express. The mini PCI is specifically more for laptops. I don't have a picture of that one listed up here, but just know that that PCI is for the expansion in laptops, and there's very little expansion inside of a laptop. You have the PCI X, which is a 32-bit with a slightly higher bandwidth than the PCI. You don't really find those a whole lot anymore in motherboards, maybe in some special ones, but for the most part you're just going to find the PCI and PCI Express. The PCI Express is the one there at the top. It's the 16, the X16 there, and it's got a very high throughput. That's what you're going to use for your graphics cards. The AGP is the old high-speed video slot that you used to find in motherboards, but really all you're going to find now is the PCI and the PCI Express there up at the top. All right, so the different types of adapters that we can put into our computer now are really, there's just tons of them. At the bottom right hand corner we have a sound card. So if you don't have very good built-in sound, or if your built-in sound isn't working, you can always put in a card with an actual sound card there, and then get your sound through that means right there. It's a really nice fix if you've got that broken and don't want to replace everything. Up at the top right you have a NIC. Now that should be on your onboard motherboard now. You shouldn't see too many cards like that, but it's a good example. Both of those two cards are just PCI cards. Now in your lower left hand corner there you see a RAID card for a RAID configuration, which we talked about in the previous episode. That'll plug right into your PCI slot or your PCI X slot, depending on which type of card you get, and then from there you can configure your RAID setup. As I said before, gamers, not the best of ideas that to go with the RAID configuration there. But if you're looking at doing a RAID configuration, that's basically what you need, is a card for that. Now, in the center you have your video card, and this is what most people, most of your younger people are really wanting to put into their computers, and most of the time they like to buy that first and then build around it, and that's really not a good idea. So far where we are in the tutorial, this should be near one of the last things that you actually purchase and put into your computer. Because you don't always need this big graphics card, and actually there can be some downsides to building around your graphics card, and we'll go into that. So one example is, say we go on to Newegg or Amazon or somewhere and we purchase a video card that's an 8GB 256-bit GDDR5 with a core clock speed of 1607 MHz, boost clock 1797 MHz, 1920 CUDA cores, and it's PCI Express 3.0. The question is, what does all of this mean? So let's get into that real quick. So your PCI Express is the first important one. That's going to tell you whether or not this card is going to fit into your motherboard. When you first picked out your motherboard, you should have written down all of these different aspects of it and kind of use this as your baseline. It's going to determine what you can use, as I've said in previous videos. So if your graphics card has only got a PCI Express 2.0, you can't use this card because it requires PCI Express 3.0. So back to the drawing board. With your motherboard, you're basically scrapping the project and starting over. So if we have that, the graphics card fits in there. Now, what does the rest of it mean? So your core clock speed, or your core speed of a video card, is the speed at which the GPU core operates in a megahertz or gigahertz. So this is really important because your GPU is basically a graphical processing unit. So it's basically got its own processor on board in the video card to kind of help the processor out here. So in this case, we have a core clock speed of 1607 megahertz. That's actually a pretty good core clock speed, not too shabby. So then you have your boost speed. Now, boost speed is a relatively new concept, and really keep your mind open on this one for a sec here, because this one kind of goes almost against what we've talked about earlier, but you got to finish it. So the boost speed is a temporary overclock that increases the core frequency when additional graphics power is needed. So what that basically means is that it will overclock only when needed in order to make up for that extra need. It's not going to overclock and continually boost like you would try to overclock your processor. It's only going to overclock when it's absolutely needed. All right. So the next thing that we move into is our RAM. So up at the top we have our 8 gigabytes of GDDR5 RAM. So you have really only two that we're going to talk about, the GDDR3 and the GDDR5 RAM. And this is RAM just like the RAM that's on your PC that we talked to in the memory, but it's slightly different because it's video RAM. It's been augmented slightly for video needs. What that means is that it's slightly different than your standard RAM that's in your computer. Your RAM that's in your computer either reads or writes, but it doesn't do both at the same time. Your video RAM does. It can read and write at the exact same time, making it much faster. That's also one of the reasons why these graphics cards are so expensive. So the more RAM obviously you have, the bigger the workbench, as we talked about in the previous episode, for the GPU to actually process what's needed. So then we move to the stream processors, which are also known as the CUDA cores. Okay, these are the number of cores available on a card. More cores, more power. Just like back in the CPU, we had cores within our processor. More cores, better. These cores are different. Obviously, here you have 1,920 CUDA cores. They're much smaller cores. They don't operate at quite the same high speed as your processor. But they're essentially close to it, where they are helping to stream your video. Alright, so the more cores, the better. You really can't go wrong with more cores in any way. What we then have, or what we should then note though, is that you cannot compare the cores across manufacturers. So AMD and NVIDIA are your two really big graphics cards companies, and the number of cores may be different from one to the other, and you can't say that 1,000 cores of one equals 1,000 cores of the other. It doesn't quite work that way. If you look at the NVIDIA GTX 670 has 1,344 CUDA cores. It's actually equal to AMD's Radeon 7970 with 2,048 CUDA cores. So you would look at that initially and think, oh, the AMD one's better. It's got 2,048 CUDA cores. Well, not exactly the case. You know, Radeon is a great company. I will use it. You know, I've used it in some of my computers. I've also used NVIDIA in some of my computers, and they're both great companies. But obviously, you get what you pay for. AMD is a little bit cheaper, so the CUDA cores don't exactly go quite as far as, say, the NVIDIA ones, which you do pay quite a bit more for. Again, both brands absolutely awesome, and I would continue to use either one. But just note that you can't compare between the two. One of the other big things that we're going to look at real quick is memory bandwidth. So the bus width, we talked about the bus already in multiple videos now, or the amount of data that the video card can actually access from the memory each clock cycle is the memory bandwidth. Alright, so the more you are doing with the video card, the more bus bandwidth that you're going to need, the more memory bandwidth. And this is basically where you have your bit rate. So up at the top you see the 8 gigabytes 256 bit. 256 bit, one of the nicest you can get out there, allows for a lot of transfer of data there. But there are a lot of cards that aren't all the way up to 256 bit. You're going to pay more to get the specs that are on the screen currently. So now again though, keep in mind that the bus rate, it works just like your front side bus. So you don't want to get this really nice graphics card and not have the front side bus on your motherboard or on your CPU in order to be able to communicate with the CPU fast enough to keep up with it. This is where it's really important that the graphics card isn't all you're putting your money into. You need to have a computer be well-rounded in all aspects. Alright, so thanks for watching this. Hopefully this helps. Make sure that you subscribe to my YouTube channel so you can get all the latest videos as they come out. Also, make sure that you check out my website, and you can find many more tips and tricks, tutorial videos, how-tos, and more videos in this series and other series, and those are all in the comments below. So, once again, thank you for watching.